topic of chemical nomenclature. And nomenclature is a systematic method of naming. Nomenclature is a systematic method of naming. And so many disciplines have their own method of naming. If you're in the health professions, you might use terms that the general population doesn't, but they have a very distinct meaning, like anterior and posterior. When it comes to chemistry, it's very often the suffix that will give us some information about the composition. So if we were to compare these, we have chlorine, chloride, chlorite, and chlorate. And if we look at these names, each of these names differ from each other by one letter. The first one, we just learned about this. This is one of our diatomic elements. If we talk about chlorine, we're typically talking about Cl2. Though without it in proper context, you really don't know if you should write Cl or Cl2. If we were talking about the pure form, then certainly we'd write it as Cl2, since it's one of our diatomic elements. If we're talking about chloride, this is an ion found in many types of ionic compounds. Chlorite has a formula of Cl2 with a negative charge, and chlorate has a formula of ClO3 with a single negative charge. And so like we talked about on day one in here, spelling does count in chemistry, because very often the difference in one letter conveys a different meaning about its composition. Now I don't expect that you know these names or whatever now, because we haven't covered them, but come the end of class in another week, all of these here should be second nature to you. You'll be able to rattle off, hopefully, a whole bunch of different formulas and their associated names. Something else now we look at when we write out chemical formulas is we need to know what it means when we write out formulas like H2O or NH3 or Ca3 in parentheses PO4 and outside the parentheses a 2. So if we were to count atoms, how many hydrogen atoms are there in H2O? I hear 2. Anybody else? How many oxygen atoms are there? If we look at NH3, how many nitrogen atoms are there? How many nitrogens?
1.
1. How many hydrogen atoms?
3.
Okay, now, this is the next question on the Socrative app. Count the number of calcium, phosphorus, and oxygen atoms represented by this formula. Once you determine the number of calciums, phosphorus, and oxygen, talk with the neighbor. Go on to the next question on your app. And if you're not sure, talk with a neighbor. See what you think it would be. We got some choices. right, get your answers locked in. Go 5, 4, 3, 2, 1. Correct answer is E. There are 8. And what operation did we use to find that answer? Multiplication. If we see something in parentheses and the 2 outside, that means we have to take 2 times the quantity that's in parentheses. So there would be 8 oxygens. How many phosphorus would there be?
2.
And how many calciums?
3.
Now the calcium's not in parentheses, so we don't take 2 times 3. We only take 2 times whatever the quantity is in parentheses. So in order to write formulas, we have to be able to count the number of atoms that are represented in a chemical formula. Another thing we need to do is we need to be able to classify our compounds into 2 broad categories. We need to classify them as either being ionic compounds or molecular compounds. And so what I'm going to do here is to make a table that will help us distinguish between them. And if we are looking at ionic compounds, we say that ionic compounds consist of metals bonded to nonmetals, with one class of exceptions. And that class of exceptions would be ammonium compounds. And when it comes time to name ammonium compounds, we will remind you that they are an exception, but otherwise we have metals bonded to nonmetals in all cases when we have ionic compounds. Compare this to the molecular compounds, in which we have nonmetals and or metalloids bonded with other nonmetals and metalloids. So if we looked at something like this here, now I understand that not everybody knows what's in this stuff, but which elements are found in salt?
Iodine.
Well, that's usually typically, actually this one says does not supply iodine. Yeah, it's an additive. Sodium and chlorine, because its formula is sodium chloride. And if iodine is in there, it has to be an additive in there. Okay? So sodium chloride is the compound found in here. And so if we have sodium chloride, is this an ionic compound or is it a molecular compound? And why would it be ionic? Okay. Sodium is a metal and chlorine is a nonmetal. And do you remember where we divide them? The staircase, sure. We look at the staircase right here, and this staircase separates the metals from the nonmetals. And so the metals lie on this side, the nonmetals lie over here. And so as long as we have, in this case, one on this side, one on the other, that makes it an ionic compound. And if it's a molecular compound, where are those elements going to be concentrated? They're going to be over here because, again, they involve nonmetals bonded to other nonmetals, or metalloids, which also lie right along the staircase. And remember that the only nonmetal over on this left-hand side is hydrogen over here. Then, another distinguishing characteristic of these is we see that the atoms are joined by ionic bonds in ionic compounds, and when this happens we say that electrons are transferred Whereas in molecular compounds, the atoms are joined by covalent bonds. And when they're joined by covalent bonds, then we say that the electrons are shared. And this concept actually isn't dealt with until chapter 10 in your text. So right now we're just basically writing them as facts. Facts that will be explained a few weeks down the road. So then, in order to have success with the naming, we are going to put the compounds into 5 different categories. So these are the classes of compounds you'll be naming. And those classes will consist of binary ionic compounds, second class will be ionic compounds, with polyatomic ions, third class would be binary molecular compounds, fourth class of compounds you'll be responsible for are binary acids. And the fifth and last class, at least for now, will be oxyacids. So again, we group the compounds into these 5 classes, and each class has its own set of rules by which we write names, though the rules are similar between many of the different classes. So now up to this stage we've defined what ionic and molecular is. So we already know those. Once again, if it's ionic, which types of elements are we going to find in there? Metals with nonmetals. And if it's molecular, we would have just nonmetals. So then let's define this next word, binary. You see binary is listed 3 different places. If it's a binary compound, what does the word binary mean? It uses 2 elements. The word binary means 2. There's only 2 options. So these are going to have 2 elements. So if we go back to this stuff here, sodium chloride. Sodium chloride has which elements?
NaCl.
That's NaCl. Those 2 elements then make this a binary ionic compound. This is binary ionic. Then, let's see, we have not yet defined acids, so let's define acids. Acids are defined like this. We say that these have hydrogen. So we say hydrogen is present and written at the front of the formula. So if it's a binary acid, a binary acid is going to contain how many elements?
2.
2 elements. One element of which is going to be hydrogen. And then hydrogen is going to be written at the
Beginning.
front of the formula. And so then if we have an oxyacid, oxyacids are going to have the element hydrogen. Hydrogen will be written where? At the front. And the other element that's going to be present is going to be oxygen. So again, if it's an acid, Acids always have hydrogen written at the front of the formula. If it's an oxyacid, it will also contain the element oxygen. And then the last one here is the polyatomic ions. And I walked around and passed out this sheet here of polyatomic ions. And this is a list of ions that you will need to be memorizing. You will also find this list in your D2L under the contents section. And today is the 2nd. And so it's under the list of ions to memorize. So I do contend that in this course there actually is not a lot of memorization, but what memorization there is usually comes at the beginning of the course. And so if you feel like we're memorizing a lot of things, we are. We've done most of the memorization here at the beginning, and a lot of the rest of this stuff this semester is going to be more problem-solving type things. But what you're going to be responsible for on the sheet is you need to know the name of these ions with the correct spelling, and you also need to know their formula with the charge. So the name with the correct spelling and the formula with the charge. Now, one of the things you're going to notice here is that in these polyatomic ions, if we were to analyze the word polyatomic, the prefix poly means many. So these literally would be many atomed ions. So there's many atoms in each of these ions, not just a single element. And then the other thing that you should notice is that most of these ions have a charge that is negative. Most have a charge that is negative. Only positively charged one you're going to need to memorize is the ammonium ion, which is only, again, has a single positive charge. Now notice that most of the negatively charged ones that we're memorizing have a suffix of ATE. So most of them that we're memorizing have a suffix of ATE. And if we look at all of them that have an ATE suffix, they have one element in common. That element is oxygen. So whenever you see an ATE suffix, you should always know that oxygen is present in there. The other thing we should look at with that is that number of oxygens does vary, and again, this is part of the reason why we're memorizing these. You will also be responsible for knowing some of those that end with an ITE suffix. And in your text in chapter 5, now you don't need to pull this out, you can look at it off of mine here, but this is page 139 if you do want to follow along. You will be responsible for some of those that end with an ITE suffix as well. So on your list to memorize, you're going to see the chlorate ion, which has a formula of ClO3 with a negative charge, but you'll also need to know the chlorite ion, which has a formula of ClO2 and a single negative charge. You'll be memorizing the sulfate ion, that's on the list that we passed out, but you'll also need to know the sulfite ion. Your list contains the nitrate ion, which has a formula of NO3 and a single negative charge, but you'll also need to know the nitrite ion, which has a formula of NO2 and a single negative charge. And if you look at all these that have 8 and ite on them, what is the difference between them? Charges stay the same, but what changes? Number of oxygens. And the one with the ITE suffix always has? No. No, because you look at sulfite is SO3. But you compare the formulas. How does the ITE suffix compare to the ATE suffix? Always has one less. So if you memorize the sulfate as SO4 with the 2 negative charge, then the sulfite is SO3 with a 2 negative charge. So you will be responsible for knowing the ITE suffix endings as well. But again, the one that has an ITE suffix has the same charge It just has one less oxygen than its ATE counterpart. So, an easy way to remember that, if you're looking for a mnemonic, once again, is to think that the one with the AT suffix, 8, one more oxygen. Okay, at 8, one more oxygen. So, with those in mind, what we are going to do then is I'm going to write down some chemical formulas here, and would like to have you classify them according to the 5 categories that are up here. And so the first one here that I'll write is going to be H3PO4. Then we have HI, Na2SO4, Ag2S, SF6, and then here's a big one, Ti, and then in parentheses C2H3O2 with a 4 outside the parentheses. And so what I'd like for you to do with these here is this. Classify each of these 6 substances as belonging to one of these categories. And so if you think that H3PO4 is a molecular compound, then write the number 3 right before it. So just tell whatever, and you can just circle it or whatever, write its classification next to its name. We'll give you about 2 or 3 minutes here. H3PO4 is which one of these? I hear 4 and I hear 5.
5.
It's 5. It is an oxyacid because it also contains the element oxygen.
I'm sorry.
Okay. HI is number 4. It's binary acid. Na2SO4 is
Is it a 3?
it's not a 3.
2.
It's a 2. Why can't it be a 3?
There's more than 2.
There's more than 2 elements. If it's number 3, it's going to be binary. Also, if it's molecular, it only would have non-metals in there. Next one, Ag2S would be,
That's a 1.
I hear 1. Any others? It is 1. It's binary ionic. Has metal bonded to a non-metal. SF6.
Is it 3?
This one's a 3. It's a 3 because we have
2 elements.
2 elements, and it's a non-metal bonded to a non-metal. And then the last one,
That's a 2.
number 2. This is an ionic compound with a polyatomic ion. We know it's ionic because we have metals bonded to non-metals, and it can't be binary because it has more than 2 in there.